Today we're going to look again at area, but today we're going to learn how to understand how to break down polygons into simpler parts. When you have weirdly shaped designs, how can we look at them as smaller, different pieces that can be put together? Your goal today, find the area of a rectangle, find the area of a parallelogram, and the area of a triangle. Come back when you're done. And here are your answers for the 3 questions. I also put the formula down that you should have used to answer them. All right, so today what we're going to do is we're going to start looking at polygons that are irregularly shaped. This is a very common thing when you're trying to break down area of like floor spaces and things that are awkwardly designed so that you can try to figure out how much carpet you need to purchase or how much wood you would need to purchase for wood floors and things like that. So right now what we're doing is we're looking at our first example, and it says that we're going to find the area of this polygon. And the first thing you should do is say, how can I break down this polygon into smaller parts? So think about the shapes that we've worked with so far. Trapezoids, triangles, parallelograms, rectangles, or squares. And how can we look for those shapes within this irregular shape? And when you look at it, you can tell that we have 2 different sized rectangles, a small one and a big one. And if all we did was draw a line in between the 2 rectangles and separate them, this is what it would look like. I can get all the information I need from the numbers that are there. So what I want you to do is copy this down before moving on so you have a good example. And yes, I will be looking to make sure you have this one in your notes. So now once you've separated the thing into 2 shapes, all you got to do is look back at which formulas you're going to need to do, or which formulas you're going to need to use to solve this problem, and you're going to do it. Now luckily both of these are rectangles, so we just have to use the formula of area equals length times width. So area equals length times width for 4.9 and 1.7. When you multiply those together, the area of that long rectangle is 8.33 centimeters squared. The small rectangle then is 2.1 times 1.3. When you multiply that together, you get 2.73. So now that we found the area of the 2 small pieces, the final step is just to add them together and you'll have your answer. So when you add those 2 together, you get 11.06 centimeters squared. So yes, you'll have to probably do a little extra math, but it makes it real easy than trying to figure out the whole other space of a weird shape that you just have no idea how to do it. Make sure this is all down in your notebook before moving on. Okay, let's take a look at one more design. So this one has a weirdly shaped polygon, but however, you can tell that at the top there's a triangle, and the bottom there's a big rectangle. Now, if we were to separate the triangle here, remember that we're going to be looking for the base, and the base at the top of this rectangle is the same as the base at the bottom. So that's how you can get your information and know that your triangle is 28 feet at the base, and the rectangle's width is also 28 feet. So break apart the figure into those 2 shapes, and then from here, all we have to do is find the area of the 2 shapes. Now with the rectangle, it's just length times width, 28 times 24. That'll give you 672. For the triangle, it's the base of 28 times 12, and then what you got to do is you got to break that, or multiply that number by half, or 0.5, or 1/2, and you get 168. When you combine those 2, the sum of your area is 840 feet squared. That's it. Okay, I want you to give this a shot, and here's what we're going to do. You are going to do number 1, and you're going to do number 2. If you want to do 4 and 5, you can do those on your own for fun, and then you can show me those later. But all I need to see is the answers to 1 and 2. Come back when you're done. All right, so as we can see for one, we almost have two rectangles. Actually, we do have two rectangles, and that's what you have to work with. So you could break it down two different ways. You could break it down as this 50 by 20, and then this 90 by, what would this be here? Well, if it's 50 down to here, this would be 20. And you can figure those two out. Those two rectangles combine to make 2,800 meters squared. That's what you should have gotten. And for number 2, it looks like an arrow, but the easiest way to break it down is a rectangle and a triangle. Now you can see that it says 10.2 centimeters all the way down. But if this part to this part is 5.4, you subtract it from your 10.2, you can find the height of your triangle. And if you combine those two together properly, you should have gotten 18.84 centimeters squared. So those are the answers you should have had for the two that you needed to do. If you got those both right, come on over and give me a high five. Okay, sometimes you're going to have to apply this with a graph or some sort of table, and you can usually figure out the area on a grid. This is an example. So Patrick was in art class and he made a design, and he used the coordinate grid to find the area. So as we can see, we have a grid here, but notice along the x-axis and the y-axis how much each square is. Each line is intervals of 5, 10, 15, 20, going up the y, and same with the x. So each rectangle is actually 5 times 5, or 25 units. This is important to know because if you needed to find the area of the entire purple spot, there's going to be a different amount of value for each one. Make sure you copy that down in your notes. So for the first row, we can see that we got 25. The second row, there's two rectangles or squares, each being 25. So the second row is 25 plus 25, which is 50. The third one goes up one more, so add another 25, you get 75. And finally, the last one is 4, so that's 100. So how would you find the area of this entire shape? Well, what you would have to do is add all those up. 25 plus 50 plus 75 plus 100, and you get 250 square units. So that shape that looks like stairs on this coordinate grid has a total of 250 square units. It doesn't look like it's that big, but remember, it depends on the length times the width of that one grid. And because it's 5 by 5, you get 25. So you got to be careful when you're looking at these, so you can see what the intervals are so you don't get mistaken. All right, we kind of talked about that already. So here are two of them, and I want you to try both of these. The first one, you can see, goes by 2s. So each square, remember, is going to be 2 by 2, or 4, when you're trying to figure that one out. The second question is going to be a little trickier. It says Edgar plants daffodils around a rectangular pond. The yellow part of the diagram shows where the daffodils will be, and use the coordinate grid to find the area of the yellow spots. You're going to have to do 2 steps with this one. Come back when you are done. All right, so let's see how you did. For this one, you probably noticed by breaking down the drawing that you had 2, 2, 2, 2, 2. Oh, I'm sorry, I goofed that up. I knew the right answer. That's always terrible when you goof it up. You should have noticed that this broke between 8 and 10, so that actually is 1. And here we have the same thing, 2, 2, 2, 2, 1. Down here you have 2, 2, 2. Here you have 2 and 1. And here you have a 1 and a 1. Okay? So when you add those all up, you get 2, 4, 6, 8, 9. 9 and 9 are 18. 20, 22, 24, 26, 27, 28. You should have gotten 29 units squared for this one. Tried to trick you by not having them all go perfectly on the line. Made you have to look a little more carefully at that one. All right, now the pond one, this one's going to take a little more work. Let me show you how this one should have come out for you. You should have gotten 72 units squared. Okay? So what we have to see is that each one of these boxes goes by 2s. So if we broke this into 2 small rectangles, we know that we go from 6 to 2, which is 4, and 6 to 2, which is 4. So we know that the length times the width of this is 4 times 4, which is 16. The bigger rectangle goes from 14 to 6, which is how much? 8. And 2 to 12, which is 10. So the big square is actually 80. However, we have to get rid of that pond space. So the pond goes from 6 to 10 on the height, which is 4. And it goes from 8 to 14 on the width, which is 6. 6 times 4 is 24. So how you solve this is you add all the yellow space up, which is 80 plus 16, which gives you 96. But now we have to subtract the pond of 24, and you get 72. So that one was a little trickier. I wanted to see how many got that right. If you did get that right, come on over and give me a high five. Now, just looking back at number 3, you might be saying, Mr. Singer, I think you did that one wrong. I think your numbers are off a little bit. And it is. I gave you the wrong answer to see if some people were paying attention. If you do know the right answer and you come over and show me the correct answer, I will give you a 50. Good luck finding out if you got it right or not. Okay, let's move on. Here is your box of thought for today. And for today, I'm actually going to make it a little simpler for you. Just do number 1. We're not going to worry about that one. So I'll explain how you can find the area of a regular octagon, 8-sided shape, by breaking it apart into congruent triangles. If you know the area of one triangle, how would you be able to know the area of the entire octagon? Tell me how you could do that. And here is your quiz. 2 questions. Find the area of that entire shape. This is here just to kind of help you, this line. The entire shape is actually the outside part of it. And then find the area of the shape you see that's shaded there. And that's it.